The volumes listed in National Electrical Code Section 314.16 are less than the volumes that would be calculated using the formula in National Electrical Code Section 314.16 because the National Electrical Code volumes include the volume of the conductors. The formula in National Electrical Code Section 314.16 only calculates the volume of the box itself. To illustrate, consider a 4" by 4" by 2" box, which has a volume of 32 cubic inches. However, in a practical application, if you were to fill this box with conductors, the physical volume occupied by those conductors would inherently reduce the amount of free space available for additional wires and devices within the box. The National Electrical Code recognizes and accounts for this reduction in usable space by effectively reducing the stated volume of the box by an amount equivalent to the volume occupied by the conductors already present. This consideration is paramount when determining the appropriate size of electrical boxes for installations. You must ensure that the selected box is adequately sized to accommodate all conductors, devices, and any necessary fittings that will be installed within it. Selecting a box that is too small can lead to a variety of problems. If the box is undersized, the conductors will be crowded, potentially exceeding their allowable bending radius and making connections difficult or impossible. More importantly, an overcrowded box can impede the ability of the conductors to dissipate heat efficiently. Electrical conductors generate heat as current flows through them, and this heat must be able to escape into the surrounding air. When conductors are packed too tightly together, they insulate each other, preventing heat from escaping. This can lead to a buildup of temperature within the box, which can damage the insulation of the conductors, leading to short circuits, ground faults, and ultimately a fire hazard. Furthermore, an overcrowded box makes it difficult to perform maintenance or make future modifications to the wiring. It can be challenging to access connections, test circuits, or add new wires without disturbing existing wiring. This can increase the risk of accidental damage to the wiring and can make troubleshooting more difficult. Therefore, it is essential to carefully calculate the required box fill volume according to the National Electrical Code and to select a box that meets or exceeds that requirement. This will ensure that the conductors have adequate space, that heat can be dissipated properly, and that the wiring system is safe and reliable. In addition to considering the volume of the conductors themselves, it is also important to account for the volume of any devices or fittings that will be installed in the box. This includes items such as switches, receptacles, wire connectors, and grounding conductors. The National Electrical Code provides specific rules for calculating the volume occupied by these items, and these rules must be followed carefully to ensure that the box is sized correctly. Failure to account for the volume of devices and fittings can lead to the same problems as failing to account for the volume of the conductors themselves. An overcrowded box can create a fire hazard and make it difficult to perform maintenance or make future modifications to the wiring. In summary, the discrepancy between the stated volume of an electrical box and the calculated volume using the formula in National Electrical Code Section 314.16 is intentional and serves an important safety function. By including the volume of the conductors in its calculations, the National Electrical Code ensures that electrical boxes are adequately sized to prevent overcrowding, promote heat dissipation, and reduce the risk of fire. Always follow the National Electrical Code guidelines for box fill calculations and select boxes that are appropriately sized for the intended application. This will help to ensure the safety and reliability of the electrical system. When performing box fill calculations, firstly determine the minimum volume required based on the number and size of conductors entering the box. Refer to National Electrical Code Table 314.16b for the volume allowance for each conductor size. This table provides the cubic inch volume that must be allowed for each conductor based on its gauge. For example, a number 14 American wire gauge conductor requires 2.0 cubic inches, a number 12 American wire gauge conductor requires 2.25 cubic inches, and so on. Secondly, account for the volume of any devices or equipment installed within the box. This includes items such as switches, receptacles, and equipment grounding conductors. National Electrical Code Section 314.16b2 specifies that each device or equipment grounding conductor counts as one or more conductors, depending on its size. For example, each switch or receptacle counts as 2 conductors, and each equipment grounding conductor counts as 1 conductor. Thirdly, if the box contains any internal cable clamps or fittings at the volume allowance specified in National Electrical Code Section 314.16b3. These fittings take up space inside the box and must be accounted for in the box fill calculation. Fourthly, if the box contains any splices or terminations at the volume allowance specified in National Electrical Code Section 314.16b4. Splices and terminations create additional bulk inside the box and must be considered. Fifthly, compare the total calculated volume to the volume marked on the electrical box. The marked volume is the maximum allowable volume for that box. If the total calculated volume exceeds the marked volume, you must use a larger box. Sixthly, ensure that all conductors are properly supported and secured within the box. This helps to prevent strain on the conductors and connections, and it also helps to maintain proper heat dissipation. Seventhly, when using metal boxes, make sure to bond the box to the equipment grounding conductor. This provides a path for fault current to flow back to the source in the event of a ground fault, helping to protect people and equipment. Eighthly, always refer to the latest edition of the National Electrical Code for the most up-to-date requirements and guidelines. Electrical codes and standards are constantly evolving, so it is important to stay informed of the latest changes. By following these steps, you can ensure that you are properly sizing electrical boxes and complying with the National Electrical Code. This will help to create a safe and reliable electrical system. In addition to the points mentioned above, here are some further considerations for box fill calculations. Firstly, consider the type of conductors being used. Different types of conductors have different insulation thicknesses, which can affect the overall volume of the conductors. For example, Type THHN conductors have a thinner insulation than Type TW conductors, so they will take up less space in a box. Secondly, pay attention to the box's shape. Some boxes are deeper than others, which can provide more space for conductors and devices. Choose a box shape that is appropriate for the application and that provides adequate space for all of the components. Thirdly, when using multiple cables or conduits entering the box, make sure to properly arrange them to minimize crowding. Try to avoid crossing conductors over each other, as this can reduce the amount of free space in the box. Fourthly, if you are unsure about the proper box size for a particular application, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that the installation complies with all applicable codes and standards. Fifthly, remember that the goal of box fill calculations is to ensure the safety and reliability of the electrical system. Overcrowded boxes can create a fire hazard and make it difficult to perform maintenance or make future modifications to the wiring. Therefore, it is always better to err on the side of caution and choose a box that is slightly larger than necessary. Sixthly, regularly inspect electrical boxes for signs of overcrowding or damage. If you notice any problems, such as loose connections, damaged insulation, or excessive heat, take steps to correct them immediately. Ignoring these problems can lead to more serious issues such as short circuits, ground faults, and fires. Seventhly, when working on electrical systems, always follow proper safety procedures. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing circuits before working on them. Never work on live electrical circuits unless you are properly trained and authorized to do so. Eighthly, stay up to date on the latest electrical codes and standards. The National Electrical Code is updated every 3 years, so it is important to stay informed of the latest changes. This will help you to ensure that your electrical installations comply with all applicable requirements. By following these guidelines, you can help to create a safe and reliable electrical system that will provide years of trouble-free service. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is important for electricians, electrical contractors, and homeowners to be familiar with the National Electrical Code in order to ensure that their electrical installations are safe and compliant. The National Electrical Code covers a wide range of topics, including firstly, wiring methods, which specify the types of wiring that are permitted for different applications. Secondly, overcurrent protection, which provides requirements for circuit breakers and fuses to protect against overloads and short circuits. Thirdly, grounding and bonding, which ensures that electrical systems are properly grounded and bonded to prevent electrical shock hazards. Fourthly, equipment installation, which specifies the requirements for installing various types of electrical equipment, such as lighting fixtures, receptacles, and appliances. Fifthly, hazardous locations, which provides requirements for electrical installations in areas where there is a risk of fire or explosion. Sixthly, special occupancies, which covers electrical installations in specific types of buildings, such as hospitals, schools, and theatres. Seventhly, emergency systems, which provides requirements for emergency power and lighting systems to ensure that essential services are maintained during power outages. Eighthly, communication systems, which covers the installation of communication wiring and equipment, such as telephone, data, and cable television systems. The National Electrical Code is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date on the latest edition of the National Electrical Code in order to ensure that your electrical installations are safe and compliant. In addition to the National Electrical Code, there may be other local codes and regulations that apply to electrical installations in your area. It is important to check with your local building department or electrical inspector to determine what codes and regulations apply to your project. When working on electrical systems, always follow proper safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing circuits before working on them. Never work on live electrical circuits unless you are properly trained and authorized to do so. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician to do the work for you. The electrical work can be dangerous, and it is important to have it done correctly to ensure the safety of your home and family. Remember that electrical safety is everyone's responsibility. By following the National Electrical Code and taking proper safety precautions, you can help to prevent electrical accidents and injuries.